Okay, welcome. And now we're going to talk about polar to rectangular form. We're going to do some more examples, and yeah, and I might have something to say about one of these. But anyway, here is the first one. So we're given the modulus, and we're given the tangent theta is 5/12. So there's a couple ways. Now you could verify, you could go through the formula, r squared, right? R squared equals x squared plus y squared, right? We're told that the modulus is 13, but remember modulus is the radius, right? Which is represented by this. And, but if you look at this, tangent theta is 5/12. Okay, which is equal to what? Y over x, right? So we could stick in y over x and verify that we indeed get 13, which we will, right? So otherwise we'd have a problem, right? Because y over x, okay, if this is true, then we should get 13, okay? So if you go 5 squared plus 12 squared, this is going to give you a square root of 169, right? 25 plus 144, which gives you 13. Okay? So you could do that, or you could notice that, well, I've got the three parts of my triangle, right? Because if you just take the triangle, right? This is x, y, and r, right? On the unit circle, or on the circle, right? So I've got the three pieces of my triangle right here. Okay? And so with that being said, then I know if I have all three pieces, then I know that this is going to be 5, this is 12, and r is 13. And so I just have to find out what my theta is, right? Okay, so now, well, in this case, we don't even need to know what theta is because, again, we're trying to go to rectangular form, okay? But we do need to know what cosine theta is and what sine theta is. Well, since we know this is theta, right, and we know the three sides of the triangle, the right triangle here, then we can easily get cosine theta and sine theta. So cosine theta in this case is going to be 12/13, and sine theta is going to be 5/13. And so we're done. We got everything we need. So we could say that this is equal to, let's call it z again. So z is equal to 13 times 12/13 plus I, well, let's put the I in the back, 5/13I. Okay, and then when we multiply through by 13, the 13s will, in the denominator, are going to cancel with the 13 we're multiplying by. So we're going to get z equals 12 plus 5I. And that's our final answer. Okay, so even though they didn't give us theta, they gave us enough information to bypass that because of tangent theta. We know the tangent theta was the ratio of y to x, and we got the modulus, so we didn't need the argument because we got the three sides of the right triangle, and we could get cosine theta and sine theta, which is really what we needed. And so that's how we get here. Now, let's say we have this now. Now here they give us the angle, they give us the argument, and they give us the modulus. So again, we're going to do this the same way we did before. Okay? So now, notice that we are in which quadrant? We're 11/6 pi. So we are in the fourth quadrant. So this is the same as negative pi over 6. Okay? Okay, so first thing I'm going to do is I'm going to use that angle, right? So I need cosine of 11 pi over 6, okay? Now here's the thing. It's going to be cosine is positive for this one, okay? This is a 30-degree angle, but it's in the fourth quadrant, right? So it's like it's negative 30 degrees, okay? So this is going to give us the adjacent, so this is going to be square root of 30 over 2, okay? Sine, on the other hand, is negative in the fourth quadrant. So sine of 11 pi over 6 is going to give us negative 1/2. Okay? And so now if I stick this in here, what do I get? I get 4 times what? It's going to be square root of 3 over 2 minus 1/2 I. Okay? And now all I have to do is distribute the 4, and I get 2 root 3 minus 2 I. And that's the rectangular form of the complex number. That's it. Have a great day.